Our guest today is Barry Traband. To many, Barry is an expert food scientist with over 25 years of experience. To me, he is a friend and a colleague who has a passion for the food industry and cares about the people who make our food. His career spanned a wide variety of food products. Barry has worked for many well-known global companies, including Weight Watchers, Garden Burger, Slim Fast, and now Starkist. Our conversation covers a lot of aspects of food science and the food industry, from the basics of what a food scientist does, to how frozen food works, to the cultural and political differences around the world for food and supplements. Barry and I can and often do talk for hours, and we've only touched on a fraction of what he has to share about the food industry, so don't be surprised to see him come back for another conversation in the future. Hi, Barry.
How you doing?
We have known each other for 25 years. And I am really excited to talk to you today because we're going to talk about the food industry and where our food comes from. Now, you and I know what a food scientist is, but a lot of people out there do have no idea about this. So if I had my 9-year-old granddaughter walk in the room right now and ask you to explain a food scientist to them, what would you tell them?
So the first thing I'd ask them is most likely, what is their favorite food? And probably probe around until they found one that was something they would buy at a store that's more of a ready-made food. And then we talk about what a food scientist does to make that food. So really it would be kind of trying to personalize it to that person to say, this is a person that takes ingredients that you know it like you would in the kitchen and then prepares something that you want in a different way, or maybe it's more convenient so you could eat it on the run, or maybe it's something that you hadn't thought about before, or just makes other ingredients accessible. So you take a product that may be really hard or seasonal and you put it in a form that you could eat it all year long. So I'd use some examples of products that 9-year-old liked to eat to kind of bring it home so they understand that.
Okay, what would you tell them what the food scientist does, though? Because, I mean, like...
That's a good question, because really a food scientist, it really depends on the task, because food scientists do lots of different things. We make the food that more enjoyable to eat. We make it more accessible, meaning that you don't have to take the food and do all the preparation work that you normally would. We also make the food available. So you think about if you're making bread is on the simplest format. Well, you start with flour and water, and then you have to mix it, and you have to proof it, and you have to bake it. Most people don't realize that because they just go to the grocery store and buy a bag of bread. And so a food scientist is the person that makes that happen, makes the processes available and the formulations and the different styles to make the 15 or 18 different kinds of bread you may see as you walk through the grocery store aisle. That's what the food scientist does. They formulate and create that product that then becomes available for them to eat.
Yeah. So I run into people who have no idea that their food was made in a facility, a plant, manufacturing.
Yes. And that is probably the most stunning thing to me is they kind of view the whole grocery store like you would view the produce section, where you know it comes from a tree or a bush and it somehow gets to the store, but they kind of they don't really think about. And I don't think it's not they don't know it. I think they don't think that something comes from a line that runs 300 or 500 packages a minute. The other thing I think people don't understand is the vast scale of the food industry, the thousands and tons of ingredients that go into making these foods on a daily basis. People think about the one that they buy. And it's almost like they think there's someone in the back room that's making that one thing that they're buying for that meal. And not really thinking that is one of 1 hour's production that might have been 10,000 of those been made in that time frame.
Yeah, I think that all those food shows out there that have how's it made and things like that. Some people have seen those, so they might be a little more educated. But I think a lot of people think the food scientist is a cook, is a chef. They don't get the scientist part. They think that you just make something up, it tastes good, and it goes out to the facility and it gets made.
Right, and I think they really, when I talk to food science people, I talk a lot about the machine-food interface, that ability to take something and reproduce it multiple times. And I think that's really where a lot of there's the science of the formulation and what goes into it to make it taste the way you want it to taste. But then there's also the science of how to make that product over and over again with people and machines to make sure you produce a consistent product day after day after day. And I think really when you talk about food science, that's the other part that people really don't think about. They think about mixing up in the kitchen and making like a concept. But when you get to running it on a production line, where you're making 500 thousands of gallons of something at a time, that's where the scale starts to lose people, because they just can't fathom, a 2,000 pound batch of dough to make bread. That just, they struggle with the size of that.
Right. And it's not simple math. It's like I can double my chocolate chip cookie recipe, but you can't just go look at your list and go, well, I'll do 10,000 times a teaspoon, 10,000 times a cup. You lose something in the translation, don't you?
Yes, you do. And you definitely lose something in translation. And things don't work in those big settings the same way they do in your home kitchen. The transfer of heat, the transfer of cold, the transfer of friction to the product all has a direct impact on your end product. And when you start looking at those sizes, you have a scale that really starts to change the way that food reacts to the equipment. And so there's a lot of the science of making that run in a manufacturing location that really takes a lot of study and understanding. And it's the thing that I love about the food industry is every part and every type of product reacts a little differently. So there's pieces and parts that kind of go along, but there's unique things about every food product you make that really you got to learn every time you start making it. I've been with a number of companies and a lot of different formats of products, and each one has its own little twist that those people that work in that industry start to understand.
Yeah. And I don't think people also realize that if you make something in the East Coast or the Midwest or the West Coast, you have to make it different to make it taste the same to everybody.
And let's also then add the complication. Now you start making it for about 40 or 60 different countries. And all those countries have different tastes. And it's fascinating. Go out and if you ever have a chance when you travel, look at the nutritional labels on just something simple like a soft drink. And you'll notice that, say, like Coca-Cola or Pepsi, in different countries has different calories, different sweetness profiles, very, very different overall delivery based on the tastes and the desires of the people that live there.
Yeah. Well, one other thing that we all encountered when we had COVID was the supply chain. And I don't think people realize it wasn't just missing toilet paper. I think they didn't realize that the food companies now couldn't get the ingredients they wanted, but you still had to have the food product. And we had to do, you and I know what reformulation means. So explain a little bit about reformulating.
So basically, food is like a car. Remember with the chip shortage of the cars, because they couldn't get the chips for the cars, they couldn't finish the cars. So you had a lot of cars sitting in lots that didn't have the parts they needed so they could sell them. Well, food's no different. If I don't have an ingredient for a recipe, I really can't make that recipe. So during COVID and then the supply chain crisis that kind of followed and went along with that, but we're still actually dealing with parts of, we just couldn't get certain ingredients because countries shut down. And, that also speaks to the whole global nature of food. I mean, I can't think of a product I've worked in the last 10 years that doesn't have an ingredient that's sourced from somewhere in the globe that's not the United States. So when that country shut down for COVID, that supply dried up. Well, then you've got two choices. You either find another place that happens to have that ingredient or make that ingredient, or you have to figure out how to formulate around it and put something else in its place. So there's a lot of complications, but the government has some issues with that because when you change the ingredient statement on the back of the package, you've got to relabel the package. So now you've got to rework your package and get your package reprinted to reflect the new world we were living in. So there was a lot of churn within the industry, and you probably, if you were close to the industry, you noticed there weren't a lot of new products that came out. First of all, the retailers weren't taking them because they couldn't reset their shelves because they didn't have help. But second, the retailers just had to focus on selling the products that are currently made because there was so much reformulation going on. You really couldn't launch new products at that period of time.
Yeah. Now, the besides having to get them, get the ingredients, we had to get the products back out. And I guess we do send some things to other countries. So we couldn't get our products out to other countries either. So they were shut.
Correct. So, so we had a glut of certain raw materials that we make food with here. But unfortunately, sometimes you needed something else to make that. I was working, and it's even worse when you have a very limited number of things that were being made. I was working during COVID with a vitamin mineral company, and there are these minerals that are only made by about 3 companies in the world. Well, 2 of them have factories in countries that shut down. So what happened was everybody wanted to get the product, but there just wasn't enough available. So it really caused a lot of product shortages on the shelves, which we all saw in the grocery store, because you physically, and it wasn't just my company, it was all the companies could not get this ingredient.
Right. Now, they also had the price of shipping went up. I mean, like that was some of the companies said, we can't get it because we cannot afford to ship that product anymore.
Yes, shipping went up from 3 to 5 times the original price. So if you're getting a container out of, let's say, Asia, that was originally costing you $2,000, it may have costed you $10,000 for the container. It really doesn't matter what you put in it. That was just the cost to get that container from A to B.
Yeah. Now, aside from our supply chain shortage, I think a lot of people think that if they eat something today that they used to eat when they were a child, could be a Twinkie, could be even a jar of jam, anything, they think it's the exact same thing 20 years later, 30 years later. And I've told people, I said, oh no, there you have food scientists who spend all their time reformulating it for new ingredients. And the one part that they don't think about is that the US, the FDA has banned certain ingredients. So you can't even put those in anymore. So things we used to eat, you can't eat now.
Right. So, I mean, you've hit on about 3 or 4 different subjects there that affect that. So first of all, you've got, like you said, the FDA would change regulations. So one of the biggest that came out in the last 20 years was trans fats. You all of a sudden had to limit the amount of trans fats and label it on your product. Well, people didn't want that. So you started formulating things that had trans fats out of the products, which means you change the products. Another thing that happens is the price of everything keeps going up, but food companies want to keep that price down because the consumers associate certain price points with certain products. So to do that, you have to cost reduce the products. So you're looking for less expensive ingredients or cheaper ways to make that product to save some money so you can keep that price point for the consumer. Those are 2 big changes that happen. And the other things that happen is just ingredients change and tastes change. So we may decide that we want to have less sugar, less salt in our diet is a perfect example. And the FDA is about to change some regulations on healthy to make the level of salt where you can call a product healthy lower, which means you're going to have to formulate that product differently if you want to still label that product as healthy with lower salt levels. So all these things cause kind of a constant movement of products out there. Now, there are still products that are made the exact same way they were before, but they're pretty few and far between.
Yeah. They also have, I always have noticed that sometimes the product gets smaller, so I'm paying the same, but it's smaller or less of it.
So they call that shrinkage. So you'll notice that coffee, the pound of coffee that you buy now is 13 ounces? Some cases it's 11, right? So that what used to be a can of coffee that was a 16 ounce can of coffee has shrunk. Those little bricks are 12 or 13 ounces of coffee. So that kind of shrinkage happens within the industry with a lot of cereals is another one where it's the most noticeable because they kind of have this huge volume, and if all of a sudden they start losing an ounce or 2, they can hide it in the package a little bit, but then after a while they've got to resize the package because there are laws that protect consumers where you can't have that package grossly underfilled. So as you continue to shrink that size, because again, we want to hit that price point. If people want breakfast cereal to be under, say, $3.99, then what's going to happen to hit that as the cost of all the ingredients goes up is the package is going to start to get a little bit smaller.
I don't eat cereal that often, but the other day I was noticing the boxes were the same size, but if you turned it sideways, they were skinnier.
Yeah. And it gets to a point, though, you can't do that because then they won't stand up anymore. So you're going to have to eventually shrink the size of that box.
I know, but that's what I thought to myself. They didn't make it. They made it smaller, but not to me. When I was walking down the aisle and I looked at it, and I looked at him and I went, "Wow, that is the skinniest box of cereal I've ever seen."
Yes, yes.
Now, you're one of those unique food scientists that I've come across, that you worked in lots of different areas.
I've worked in a lot of different industries.
A lot of people stick with one. They'll be like, they know how to make candy. They know how to make breakfast cereal. They know how to deal with meat, ice cream. You have done lots of different ones. So I want to go through your career about products. We don't have to talk about either. I don't even know if you want to talk about what the companies were, and I don't know if you even remember the list in their order. I have it.
I can tell you that I started out in frozen foods. So I started out with frozen meals with two different companies, working on frozen prepared both dinners and entrees. But in that, we also had an opportunity in the second company to work on frozen desserts, including ice cream. So that's a whole different level. So frozen foods is pretty fascinating, and I always say it's probably the most diverse. When people say it's diverse, I can remember doing a project where you had a meal on a plate, and you had a protein on it. Let's just say it was a slice of meatloaf. Then you had to formulate a gravy for the meatloaf. So we were making the meatloaf in the plant with ground raw meat and then cooking it. So that was a seasoned meatloaf. Slice of that, you put gravy on it. That's a gravy recipe. I'm up to 2 now. Now I've got potatoes next to it, so I've got to make mashed potatoes. Then I've got to put a gravy on the mashed potatoes. By the way, it's a different gravy. Let's say it was a different one. So in some cases, I had a ham slice with a gravy on it, and then I put something else. So a starch with a gravy, and then I've got vegetables. Well, vegetables freezer burn badly, so I put a butter sauce on it. So I put a sauce on it that protects I tumble it in this sauce. It protects the vegetables from the freezer burn. And I put all these in a tray. So you've got 6 different recipes, essentially, you're juggling, trying to make them all taste good. They've all got to hit the plate within the same 50 feet of line and somehow dispense that all and get them on there in the right way so you can get a lid on it and get it in the freezer at about 130 a minute.
And then it has to also go in the microwave or oven and cook all together and be all done at the same, like not mushy vegetables and underheated meat and raw potatoes. And
preferably, the sauces don't run around the plate and all mix together and make it look like you put the food in the Cuisinart. So that's the reason why there's a lot of dividers on those trays, because that's really hard to do, keep things where they belong. My first project actually was on a tray that didn't have dividers. So it was a nightmare project to try to keep something like a mac and cheese from when you thaw it out, melting down and getting all in the other parts of the product. So
probably fish sticks.
Exactly right, something like that. So it's an interesting. There are a lot of interesting challenges in that area of frozen foods.
Okay, so I talked to a guy one time who worked for. What's the cheapest frozen dinner? What was it used to be called?
Michelina's?
No.
Budget Gourmet?
Budget Gourmet, I think it was.
Budget Gourmet, yeah.
They were like $1.99 at the time. Okay. Mm-hmm. And I asked him, I said, as a food scientist, doesn't that sound like a terrible job? You're trying to make the worst tasting product on the market. And I thought he'd get mad at me. And he says, you know what? The challenge is not making the product, not making it taste good. He said, the challenge is they come to me and say, you have to make that exact product for a nickel less. And he said, so I have to figure out how to make the same product they took a nickel away from me and redo it. So he says, it's not about cooking. It's about, it's be about proud of that I could finish the project to the parameters they wanted, not that it was some gourmet delight on the shelf.
And you've probably talked about the one part of the job that most food scientists don't want to talk about, which is the fact that at the end of the day, that food cost is sort of what you formulate to, what you have to hit. Because a lot of the other costs in your operation, especially assuming you're putting on an existing line with existing processes, You know what all those fixed costs are going to be. You know how many people you have on the line and how much your overhead and your lights and your utilities cost. But the food cost is the biggest part of that we call cost of goods of the product. So the challenge for us is going to be always that to hit a price point, whatever that price point is decided, you have a very limited amount of cost of goods that you have to hit, and you have to figure out how to develop as good a tasting product as you can to hit that magical price point.
Right. Well, people say, a lot of people have told me that the package, the marketing, the container, the shipping, the processing outweighs the food ingredients so much. It's like it might cost you a dime to make this food product, but it costs all this other money to get it out the door. And I don't think people think about that.
And it's really it's a little hard to explain to people, because if I say I've got for that $3 meal in front of you, or the $3 food you're eating right now, there's 57 cents worth of food in there. But don't forget, that's 57 cents bought at scale. I'm not paying the same for the ground beef that you're paying in the grocery store, because I'm buying truckloads of it. And I'm buying my ingredients in a different size. I'm buying 100-pound bags of starch. So it's a little, you can say that, and you can say, wow, there's a lot of other things that go into that. And there is. You have to pay for distribution. You have to get it there. You have to freeze it. But you're right. The food is probably a smaller part of what you're delivering. But in food products, it is still a pretty major part of that total overall cost.
A lot of people I talk to, when they hear about food scientists, their first thing is, oh, I like to cook. I love to cook. And I say, then you should be a chef, because a food scientist, that's actually a small part of their job. I said, like you said, you have to sometimes fit a product to a price point. Sometimes you have to fit it to a nutritional label. It has to fit all the things on the nutritional label, and then you have to make it taste good. So
I spent a number of years working for a large meal replacement drink company, which is a national brand, which
you can say it.
Yeah, Slim Fast, which is probably one of the most challenging products and most technically challenging products I've ever worked on, because you're supposed to deliver in a 12-ounce can at the time it was a can of product. You're supposed to deliver all the nutrition that the government requires and that humans need for a third of their day in that 12 ounces. And oh, by the way, you have to it has to taste good, and it has to last for 2 years in that can.
Oh.
Oh, and now technically it is a low acid food, so we had to go through an aseptic process, which is a very heat intensive process to heat it up, to sterilize the can, to put the liquid in it, and seal it up hermetically so it'll last for 2 years. So it was technically and technologically one of the most difficult product lines to make, because, as you know, high acid foods are much simpler, but low acid foods are very challenging because of the risk of botulism and other organisms that can grow in them that can kill you.
Okay, so tell us, for those who don't know those, give me an example of low acid and high acid.
So it's if the pH is below a certain specified level, it means it's more acidic, then it's fine. You don't have a problem. So that is a high acid food. So it's high in acid, and the acid,
like tomato juice.
Right, and tomatoes, and it inhibits the bacteria growth. Now, if it's above that level, that is considered a low acid food, and therefore it has lots of things that grow, whether there's oxygen present or not. And a lot of those things that grow can make people very, very sick or kill them. So you have to treat that low acid products, and the name is weird because actually the number on the pH scale is actually the higher numbers.
Yeah, but it's also it's dairy, milk, yogurt. What else? What else is low acid?
So most of the stuff you usually see refrigerated with relatively short shelf lives are considered low acid foods,
right?
Or high acid food. No, low acid foods. Low acid foods. So doing it in a shelf stable environment makes it really challenging. And so I think, as you're talking about food science, anytime you're trying to take something that typically has a very short shelf life, whether it's dairy, fish, which I work in now, and turn it into a shelf-stable product with a multi-year shelf life, it takes a lot of processing to do that. It may be as simple as canning it, heating it up in a retort, but it still takes a lot of processing to make that work.
Okay, now you have to explain, like you explain to a 9-year-old, what aseptic is.
So aseptic process is where you heat up. So in the case of Slim Fast, I'll give you that example. You put a sterilized product, means you've heated it or treated it in some way to make sure there's no organisms in it, and you marry that with a sterile container. So when you see those little juice boxes, anything that, and now juice boxes are usually have the higher acid, but the juice box process is the same kind of process. You sterilize the package, you sterilize the product, and then you put the two together and seal it in a sterile environment before you kick it out into the rest of the world. With Slim Fast, it was a can. We had a really high steam heated environment where we sterilized the can, then we put the liquid in it, sealed the can, and it came out. And still at a very high temperature. Whereas you're talking about the other process is you put it like a typical can, you put it in a retort, which is a big pressure vessel, looks like a small submarine. You put a bunch of cans in there and you heat it up under high pressure to a high temperature for a period of time. And again, it's that time and temperature is what you need in all these processes to kill those microorganisms to make sure they're safe.
So this is retorts like home canning. I can something at home.
It is a lot like home canning, yes. It's except it's just on a much, much bigger scale.
Right. Because I made lots of jam and jelly this year, and I canned all of it. Even though my grandmother used to put wax on top of it.
But in that case, you have a lot of sugar in there, which retards and stops the bacteria growth. So that would be considered more of a stable food, whereas the things that when you can it in a ball jar with the rubber gasket on the lid, that is more of a retort process when you're canning it, heating it up, and then cooling it down.
Yeah, that's what I do with my tomato sauce, my spaghetti sauce.
Got it, exactly.
Yes. Okay. So you start out in frozen food, and I did all those, and then you moved to a we'll touch on the Mrs. Smith's, because that was pie, wasn't it?
That was pie. So it was frozen still, but now we were into the fun part of the business, right? Everybody wants to talk about dessert.
These are all pies that were baked and ready to eat. Or were they ready to bake?
No. So the fascinating things about pies. So there's two types. We made two types. We made ready-to-eat pies. And those are usually what we call cream pies, which are your lemon meringues, your chocolate decadents. They're more like pudding pies. Those are ready to eat. And then pecan pies, because pecan pies are baked. Because otherwise a pecan pie, if you ever made one, is really liquid. And so we would bake those first. But if you look at a pumpkin pies are fascinating because you make the pumpkin pie and you basically make the shell and you put it on the freezer belt and then you carefully dispense the pumpkin filling in and then you run it into the freezer. So it freezes. So the pumpkin pies are raw.
Oh, okay.
So if you defrosted a pumpkin pie right out of the freezer case that does not say pre-baked, it's liquid.
Oh, so you have to bake those.
Then when you bake it at home, it sets the custard. And a lot of the apple pies that we make, or the higher end apple pies we made, were also unbaked.
Completely unbaked? Not even par baked?
No, completely unbaked. We did some pre-baked, but yeah, there's a lot of pies out there you buy now that you're buying to put in the oven. And what that gives you is the smell in the house. It gives you the consumer experience. And quite honestly, with today's consumer, that's cooking.
Yeah, unfortunately.
I cooked this pie. And you did. You did cook the pie. We just put it together for you.
Well, I go to restaurants and I swear every time they trick me, it'll say home-baked pie. And my brain says homemade pie. So I order a piece, it comes out, and I look at it, and I can tell it's a manufactured, there's no way that they made that edge on there. And you can just tell that it's not homemade. And sometimes I've said something and they say, they point out it's home baked. We baked it. So we made it right here. Some of the younger people say, no, we made them. I saw it. We made them.
So if you want to ever see if your pizza place is making their own pizza or if they're buying the crust pre-made, take the pizza slice and turn it over. If you see rings on it, like it's been concentric rings, like a circle, they bought a pre-made crust. So because it's a spinning process where they press it and spin it.
Okay.
So if that pizza crust has those lines on it, they didn't make it in the back.
Oh, I thought you were going to tell me like it had a texture, because I've seen some of them that have like a little grid texture, but that's probably from their pan.
Sometimes, yeah, it depends on the place. But yeah, I do a lot of that when I go to pizza restaurants. I pick them up and look underneath and see if they're making their own crust or not.
Yeah. Well, but I mean, I just felt like I was cheated when I thought it was getting a homemade pie, and it was home baked pie. Right. So did Mrs. Smith's do food service too?
We did do food service pies, but the pies weren't bigger. Costco has really changed the game as far as the size of pies people expect nowadays. When I was there, a 10-inch pie was a big pie, and I think those Costco's like 14 inches now, so they're insanely large.
I will have to say I've never bought a pie because I make my own pies. So I'm not a Costco. And okay, so we just touched on something: food service versus retail. I think that when people go to a restaurant, they think that everything was made in the back. And I don't think they realize, it was kind of a shock even to me years ago, not shocked anymore, years and years ago, to find out that a lot of restaurants bought their soup from Campbell Soup. But it wasn't the Campbell Soup I got at the grocery store. It was a totally different Campbell Soup, obviously higher quality, different, recipes, different kinds. So let's go with that.
So food service is a really interesting place to go. So the way it started, so let's face it, 50 years ago, restaurants made most of their own stuff. Where they started to really make the inroads was a lot of the side dishes. You think about a restaurant, when you go to a restaurant, you're buying the main dish. And especially what we call a quick serve restaurant, which are your Applebee's, Chili's, restaurants of that, where you still sit down and have some weight on you, but they're turning tables pretty quick. So we call those QSRs, quick service restaurants. They started, it's like, well, we want mac and cheese. Well, Stouffer's makes a really great mac and cheese, and they make it in this great big pan. Why don't we put one of those in the back, and we can heat that up, and as someone orders mac and cheese for a side dish, we'll take a scoop of it, put it and we'll put it out there. So you started seeing it creep in. So it's not the main dishes, but it's the side dishes. And then it turns into sort of an example of what you said with the, partially prepared. So a lot of things in restaurants nowadays are partially prepared. Bread in sub shops is made and ready in the shape, and actually in big boxes. They put in the pans, they put it in their magical little ovens that blow that bread smell out into the restaurant, and it proofs it and then bakes the bread. So really, they didn't make the bread there, but it's fresh baked daily.
Yes.
In the restaurant. So they're baking the bread, but the hard work, all the mixing, a lot of the initial work is all done at another bakery miles and miles away, and then it's brought in on a truck.
But I mean, food service isn't bad for restaurants because it lets you do what you're really good at. And maybe, like, I'm really bad at making soups. So if I had a restaurant, I wouldn't mind buying those soups so I could concentrate maybe on the pies.
So soups, side dishes, and desserts in a lot of restaurants, including really high-end restaurants, are a lot of times brought in because it's easier. They bring them in because it's easier to make them in other. Now, the other thing some restaurants are doing is something you call a commissary, where they make, if it's a chain restaurant, they'll make in a central location scratch recipes in a big commercial kitchen and then put that on trays and in trucks and ship it out to the restaurants.
When COVID hit and all the restaurants closed, it was interesting. I don't know if people noticed. I noticed HelloFresh and Green Chef and all those places, all those meal kits, they were just about to go out of business. I mean, COVID saved them, and they did very well. And they have that kind of commissary thing where they'll make part of the meal for you. They always do the marinade or the seasoning mix. Sometimes they chop up the cabbage for you or the onions, and they send it to you in all these little bags. And so they do that in a central area like that.
Yep, it's exactly the same concept.
But they really don't cook any of it, even though that's a whole different thing.
That's a whole different thing, and that's a whole different supply chain.
And all the people now learned how to cook.
But they're also learning how to cook when it's partially prepared for them too.
And that's okay. I enjoyed those rather than going to restaurants. I did them not because I don't know how to cook. I did them because I was bored with all the things I had, and I thought, let's see what they do. And they put some things together that I would never put together.
Well, I think that's one of the cool things that food science allows us to do. If you think about the food you ate when you grew up, for me, 1,000,000 years ago, right?
Not quite.
I remember when pizza was a Chef Boyardee box mix. That was the only. We didn't have a pizza place in my
With
hometown.
sprinkled cheese.
With sprinkled cheese and
it was powdered.
Yep, powdered cheese and a little can of tomato sauce and a powdered mix to make the dough, and that was pizza for my family growing up until I was about in high school. So think about how that's changed. Now you go and there's a wall of frozen pizzas, and you've got 6 pizza places on speed dial in your town that you could call. And a lot of that has been done by food scientists. They've made all those frozen pizzas. They've made it possible to make that happen. Now, obviously, a lot of help from engineers and other people also, but essentially, we've been able to bring that, what was a very limited restaurant experience, go get in the car, get it, bring it home, into a situation where it now is easy to do. I don't even think people really appreciate the fact that when you get a pizza delivery, the pizza comes out of the pizza place partially cooked. And it goes into a special rack in some of the cars or in the bag they put it in, and it finishes its cooking process during the trip.
I did not.
Because they know it's going to be 30 minutes or less.
I didn't know that.
So, because otherwise what you're going to get is a very overcooked, very cold pizza. So that pizza comes out with a lot of what we call latent heat. So heat's in it. So it's still cooking and developing the dough and changing the way it tastes. And as you put it in there, and there's even ones that actually have a little box that's made to kind of keep the heat in, to keep that process going. And that's why you get a piping hot pizza that's perfect from that delivery person, assuming they're on time.
Yeah. When I tell my kids that we used to eat the pizza with powdered cheese, they can't even believe it. And I remember we had no pizza place. We had no McDonald's. We had no fast food whatsoever. We had too many kids in the family to go out to eat, So we didn't do that. And now you have all these restaurants that have popped up. And, my clue to most of these is that the turnover of the kitchen staff tells you that those people are not really cooking back there. They're just they're assembling food and heating it up.
Especially as you look at more of the quick serve family style restaurants, definitely you're right. I mean, there is still a lot of prep and work at the higher end restaurants and the nicer white tablecloth restaurants. But you're right. There is a good bit of kitchen work. And let's face it, kitchen work is very repetitive, much like what happens in the food industry. You're trying to repeat that same meal in a kitchen 15 to 25 times a night as opposed to 300 a minute on a production line.
When I first moved to Chicago, I met a woman. She lived in my building, and she was the food scientist for McDonald's. And I didn't realize this until I'm talking to her, that she was the only food scientist. And this is really before I got into the food industry, so I didn't really understand too much about it. But shortly after that, when I got into it and I talked to her, she was bored with her job because people didn't realize that McDonald's doesn't make anything. They just assemble it. They get hamburgers from one company, buns from another, sauce from another, lettuce from another. So she was just assembling product all day long and letting people taste it. And then her biggest part of her job was to test how long you could leave that hamburger sit on that warming plate before you couldn't serve it to somebody.
So you bring up an interesting point. When I was with a couple of frozen food companies, we would have to make, when we did our food service cuttings. Now, when you look at in a buffet, you see that's called a steam table, and the full thing is full pan, half pan. We would put a half pan and we let it sit there for 2 hours, and then we did the tasting. So between 2 to 3 hours, you were tasting the product because that's how long it had to be good on that steam table So not just right out of the microwave like you do with the retail products. Now think about that. That's really hard because mac and cheese, as an example, was a big product they made. 2 hours on the steam table is a very different product than making that is a very different proposition than making one that you eat 10 seconds after you pull out of the microwave.
When this woman wanted to leave her job at McDonald's because she was bored, they said a promotion from the food scientist job was going to be an assistant store manager. And so she took it. She went to work as assistant store manager. And I remember she was making like $14,000 a year. Well, I just want to, my comment is fast forward now to present day McDonald's. They probably have 65 food scientists, PhDs. By the way, she was non-degreed. PhDs working in what she used to do.
It's amazing.
I'm trying to figure out what they do because we're eating this. No, I shouldn't say that because we're probably not, but we're eating the same hamburger. It's the same menu. You know, they've added a few things, but I don't think they've added enough to add 65 people to the payroll.
Well, but what you also don't see is they've had to adapt those products to the back of a McDonald's now, what it looks like and what it used to look like. Now I'm going to go forward on my resume here. The next job in my resume is germane to this because when I worked at a company that made a meatless patty, one of the first meatless patties called Garden Burger, we were trying to get this into Burger King. Now, Burger King uses a different cooking method. McDonald's uses a griddle, right? So they cook their hamburgers on a flat metal griddle. Burger King has this belt-driven flame broiler that takes the meat, the patties through and subjects it to high heat and cooks the meat and kind of spits it out the other side. Trying to get the veggie patty to work through that process was very, very challenging because it wanted to burn. Because the sugars in the vegetables wanted to burn as opposed to didn't have all the fat the meat had, so we had to do a lot of interesting things to it. But the back of the restaurants, even from then to today, has drastically changed in the number of people it takes to make it, in the way they set up their stations. So they've had to morph a lot of the processes that used to be very manual to make them easier to do and speed and faster, so they can do it with less people.
Yeah. Okay. You brought up Garden Burger because I wanted to bring that up because Garden Burger was the first thing. Everybody wanted that for all the vegan people, the people who couldn't or didn't want to eat meat. So now we have the Impossible Burger, the Beyond Burger, so maybe I'm asking you a question you know the answer to, but I think you do. What's the difference between a Garden Burger and your Impossible Burger?
The only animal product in a Garden Burger was a little bit of egg that was used to help hold all the vegetables together. So Garden Burger was primarily rice and mushrooms and onions, but with some other and different flavors for different vegetables. They were kind of pressed together in the same machine that makes a meat patty, the same type of machine, and then pre-cooked. So it was cooked to make it set and hold together. So it wasn't trying to be a hamburger. And I think the big difference between that and what you see now is it's trying to look and taste like a meat. So it's a meat analog. When I was at Garden Burger, we also started making the first soy patties, which was a soy protein product flavored like beef. It doesn't hold a candle to the current Impossible and Beyond Burgers that we have today. But got to also realize that was 20 years ago that we were doing that. And at the time, that was really far out there and cutting edge. And as you said, Garden Burgers, which you brought to the picnic for your friends that were vegan or vegetarian or just didn't like hamburgers. It was a good alternative. So it was a really fun, that was a really thrilling product to work on.
But Impossible Burgers are not even vegetable. They're lab-generated meat.
Well, they are actually plant-based. But that's the next thing that's coming. Just Foods just had approved the cell-cultured, essentially lab-grown chicken nuggets that they make. And that is the next frontier from the FDA standpoint, is getting that meat grown from cells that are from an animal but don't involve an animal.
I think Impossible does a chicken now too. Because I think somebody told me, I talked to somebody and they said, I said, what's better, the burger or the chicken? And they said, chicken. And I was like, oh, okay.
But it's a great example of how the food industry continues to progress, especially on these areas where we see is cutting technology. Because to be honest, the first meatless burgers, the soy burgers, were not, the Boca burgers were the first one. Not very good, right? They weren't, compared to where we are now, fast forward 20 years down the road with the technologies that have changed and everything else, it's a wholly different proposition.
Yeah, we used to call them mystery meats.
Yes.
Because it could take on any form it wanted and things like that. Well, I talked to a gentleman years and years and years ago, and I asked him what his claim to fame was. As a food scientist, thought, well, what did you make that we would know? And he said, well, I invented the chicken nugget. And I thought,
wow,
you did? And then I thought about it. Everything we eat had to start somewhere. So nobody had chicken nuggets on the radar until this man made it. And he made chicken nuggets. And now who doesn't know what a chicken nugget is? Who doesn't eat a chicken nugget?
But chicken nugget was a natural progression from the fish stick, which was out first. So think about it. A fish stick is chopped up fish that's formed into a square, battered and breaded, and fried. There's not that much difference between smashing a bunch of chicken together. It's just a different form, different look, but essentially the same process that was being used in fish sticks for years.
Yeah, but I mean, what an aha moment. Everybody went, why haven't we done this before? And so it now is everything, everybody eats them. Okay. So you went from Gardenburg, you went to Reese Foods.
So that was very different. So this is now I was into ethnic food, Mexican, Hispanic food. Reese Mexican Foods makes El Monterey brand, which is a very popular, very large company now. And it's burritos, it's taquitos. It was enchiladas, a fascinating business to be in. Very different, but again, going back to a much more complex product where you've got to make the tortillas, you've got to make the filling, you've got to marry those together and get them in the freezer at speed.
Now, weren't they hand rolled?
At the time, and I think some of them still are, but at the time, all of them were. Even the 10-pack burritos that sold for, I can't remember, a pretty low price, were all hand rolled.
So how many people were in that facility?
There were quite a few. I can't tell you the number. It was quite a number of years ago, but I can tell you that they were approaching between 15 and 25 a minute in the speed they were rolling those tortillas.
Wow.
So it was fast. So they'd literally be finishing the roll with one hand and starting the roll on the next one with the other hand. It was fascinating to watch.
You had a short stay we went into Horizon Mill in Cargill. Tell me a little bit about that, because that was kind of just a little blip there.
Well, it was an interesting time. That was right after 9/11. So I was between jobs when 9/11 hit, which is essentially the pre-COVID type event where the job market just went flat. Everybody didn't know what was going to happen. Planes weren't flying for 2 weeks. As you know from the industry, you couldn't get a job interview, you couldn't do anything. And that for a number of months, it really just kind of flattened the industry. So I got a job with Horizon, which was a part of Cargill. And that was interesting. It was my first time in commodities. And commodities is a really different, where now I'm at the other side of the table. I'm trying to sell people like I had been ingredients. So I'm trying to support the sales team, trying to sell flour to bakers and people like that. And that's a real difference. So it was much more of a quality-focused job, really more focused on the quality assurance side of things. We had a large number of flour mills with quality groups in. We were trying to make sure that we could keep the flour. And the interesting thing about commodities that people don't realize is flour changes year to year to year to year. Every crop gives you a different. So we had a huge testing lab. We'd bring in samples of the wheat we were buying and testing it, trying to decide how we were going to blend different lots of wheat together to keep the flour the same protein and the same other attributes of the flour for the people baking it.
When years and years ago, I was working with Kroger, and they wanted me to find them a bakery scientist because they didn't understand why their cakes cracked in August and September. I think it was, or the fall, why the cakes cracked in the fall, but they didn't crack in the spring or the summer. and they didn't know why. Now, obviously, there was no Google for them to figure this out. So they wanted to hire somebody who could tell them. And so I started out trying to figure this out and call people. And they actually easily told me the answer. They said, well, wheat, winter wheat is different than spring wheat and summer wheat. And so they have to, and what their solution was in the spring, they would buy enough cake mix to last them the rest of the year till they could order again in the spring, because they didn't know anything about these crop changes. And so I told them, they hired the food scientist, and they no longer had to buy warehouses full of cake mix. They just had to reformulate. The cake formula in the spring was different than the summer than the winter. And they just had to reformulate all of it.
And exactly, and that's the truth. And people don't realize that ingredients change through the crop seasons, and flavors change. I mean, if you're buying a commodity, you may have peppers are a great one for this. Where if you're buying an IQF, a frozen pepper piece, it may jalapenos may be hotter one year than another year, and actually it may be different crop field to field to field. So trying to keep a consistent hot sauce or spicy product is challenging, because it'll tend to do this throughout the year. So it takes a lot of work and a lot of effort to try to keep those ingredients consistent across the product.
What do they do? Just add heat to it?
Well, no. You tend to end up really blending things, and a lot of times it's scale. It's scale. You're blending things, or you measure the heat level. It's called Scoville in the different batches, and you actually adjust your batching to how much you put in.
Okay, so you got a really hot batch and kind of a mild, and just mix them together. And you get medium.
Or you put less of the hot ones in and more of the mild ones in.
Now, you talk about scale a lot. I don't think people understand. I don't think they realize how big some of the kettles are, some of the conveyor belts. What are some of the biggest ones that you worked with?
It's hard to, typical, if you're working on a sauce with like a frozen meal, you're typically working with a kettle that holds 300 gallons. But realize on some lines, you may be emptying that kettle every 10 minutes or less. So you're flipping those batches. You've got a number of them, and you're making batches, and you're draining the line is draining that kettle, say for mac and cheese. You're draining a 300-gallon kettle in 6 to 8 minutes at line speed. So you've got to continually be making new to feed that line all day long as the line's running. So for 8 hours a day, you're pumping that stuff out. So and then if you're making other products, you may be dealing with much larger batches where you're looking at, when I was making the meal replacement drinks, we were looking at batch tanks that were 22,000 gallons.
How big is 22,000 gallons?
Let's put it this way. You had to wear fall protection to go up to the top of it.
Wow.
It's so tall. Right. It's very tall. We had a room, and we had a forest of them because we were making so much. You drain those tanks pretty quickly too at the speed of the lines. So yeah, you really, when you see the food plant with big silos outside, think of some of those big silos full of flour or sugar or liquid sugar, or pick an ingredient that's kind of a common ingredient you use a lot of in a recipe. That's what those big tanks are for.
Yeah, vanilla.
Right, and they may be filling those tanks multiple times a week to supply the plant.
The general public doesn't appreciate that. That's why food companies are like along railroad tracks, because they comes in by train, and it's pumped in, and it goes through pumps. Like the room that's holding the corn syrup or the liquid sugar could be 100 yards away from the production line. Absolutely.
And I think that's one of the fascinating things is, and then, think about oil and how much oil would it take to fill a fryer. If you're thinking about a fried food that you buy, say French fries, and you've got a fryer that's 8 feet wide and 40 feet long, you have to fill with oil to push all these cut potatoes through to make French fries.
I also realize, I know this, and you know this, but I don't think other people, is that a food scientist working in commodity companies selling ingredients, it's kind of like, well, why? Why don't you just have a salesman? But what I'm touching on is ingredient functionality. I don't think people understand that to sell it to somebody, you have to know how it works.
Correct. So let's use your flour example, which is a great one. When you make a cake, you use what we call soft wheat. So it's a low protein wheat. So you're looking at a protein well below 10%. That makes a soft kind of a cupcake or a cake. Now, if I want to make an artisan bread, I'm going to be pushing my protein up to 14, 15% because I want that structure. I want the gluten in there, which causes the cells to hold together, to be hard so I can put my butter or my jam on it and make it nice. And then there's gradients in between that. So you're actually formulating the flour, looking at the wheat, grinding the wheat to make a flour for the specific purpose that you want. So you wouldn't send high protein flour to a cake plant. And each product in each bakery you send it to is making a slightly different portfolio of things. So you really would, if you're making a truckload of flour for a given bakery, it's a very specific recipe that you develop with that bakery to supply them for a crop year. And when the new crop year comes around, you reformulate that mix for them to make sure they get a consistent product so their consumers don't see the difference.
Yeah, I think 20 years ago, 25 years ago, a lot of the commodity companies depended on their customer knowing what they wanted. Because if you think about it now, why didn't Kroger call their suppliers and say, why are we having this issue? How can we fix it? Now, a lot of R&D staff, research and development staff, is in the commodity ingredient companies waiting for the customer to call them and say, how do we use this ingredient? Because if you solve their problem, they're going to buy it.
Right. Just like a lot of companies, the companies making the finished products have cut their staff down, just like restaurants. So we've got a lot less people. So I'm leaning on my flavor houses and my ingredient vendors to tell me what I need to use to solve a particular problem. And that's kind of throughout the industry. As the industry has reduced their investment in their product development staffs, and I don't really want to call them R&D, call them product development staffs, the vendors have had to step up and increase their ability. And so what it gives you is also ability to really partner with vendors and really work closely with them. And you have to develop these partnerships now because they're going to help you out of a bind. They're going to help you out of a jam. And if you don't do that, then you're not going to be able to solve those problems because you don't have the staff to spend the time on doing the repetitive studies you need to do to get to where the vendor already knows you need to be.
And I think when we make things at home, we don't think about how some of these ingredients provide a function. I've talked to people and they say, well, I take all the salt out of my recipes because I'm supposed to be on a low salt diet. And I'm like, that salt had a function, And I think many people know from making the mistake, you can't take artificial sweeteners and replace sugar completely in cooking. You can in your coffee or your tea, but you cannot bake, so people figure that. But I think that these scientists at the ingredient companies will help people and say, you can't replace, that's not an equal replacement.
This is the constant thing that food science face with. People don't really understand. So if you show someone a product and it has 500 milligrams of sodium, they may go, oh, that's a lot of salt. And then proceed to take their salt shaker and put 2 grams of salt on their food. Now, they just put 2,000 milligrams on their food. So numbers to the general population sometimes don't translate well. Because 500 looks bigger than 2 grams of fat or 5 grams of fat, but it's really a lot smaller because it's milligrams.
I guess that's another subject. People can't read nutritional labels.
Well, people can read nutritional labels, but I think, again, we read them like we do when we go through the grocery store. We're just kind of whizzing by. We always say that person has 2 seconds to look at your product at max. So when you're talking about a product, they have 2 seconds to either decide they're going to buy it or not. That's the average decision time in a grocery store the consumer makes as they whiz by your product on the aisle. So you somehow have to have that big impact from the picture and the name and everything else on it, unless they already buy it and they're just coming back to buy what they usually buy. So I think that's the same thing with nutritional labels. They'll pick it up and they'll go flip and they'll look at it and they go scan and they'll put it back. Now the beauty of the nutritional label is all the things are in the same places most of the time on the label, which makes it a lot easier. But truly understanding what those numbers mean in the scope of your daily diet is really something that I think people struggle with.
Right, because there are some products out there that it's okay they're a little higher in like carbs because they're higher in protein, and so people just look at the carbs. Now the other day I did pick up a muffin and it was 66 grams of carbs, and I thought there cannot be any redeeming quality in this muffin that causes me to eat 66 grams of carbs.
Right. But the other thing that people miss is that carbs are not necessarily bad, because don't forget, when you do a nutritional analysis, you analyze for the total calories, you analyze for fat, you analyze for protein, and then what's left to make up the calories between the fat and the protein is carbs. It's a straight subtraction. Well, that includes all your fiber, which is really good for you. Americans don't get enough of. It includes all your added sugars and your natural sugars. And that's the other thing people don't understand, the difference between an added sugar and a natural sugar. You can say, I took all the sugar out of my fruit salad. That's great. But you still got a ton of ton of sugar there. So you have to be careful what you're asking. If you say, I'm on a low-carb diet, I'm going to eat fruit salad, you may want to walk away from that.
Well, we're going to switch. You went to a really interesting company for a while, Amway. Now you're in a totally different area.
And that was a very different world. And I was hired for a very specific role in Amway initially. I was hired to lead what essentially was their captive internal ingredient supplier. So Amway, as everybody knows about Amway in the U.S., but Amway is one of the larger vitamin and mineral suppliers and makers in the world. So they make a lot of vitamin and minerals. They also make protein powders and bars and all kinds of other things. But my job was to take the botanical ingredients. So they actually had farms in Brazil, Mexico, U.S., and they would harvest these crops, and then we would extract what we call the phytonutrients out of them, the parts of the plant that are beneficial to humans. And so we were tasked with deciding what crops to grow, how to and then physically how to get those parts of the plant that we want, the beneficial parts, out of the plant and in a format that we could then put in a tablet or a capsule for people to take with their supplements. So it was a fascinating job because it involved ag research, a lot of heavy chemistry in the analysis of those crops, then a lot of processing technology to figure out how to separate the sugars and the fibers from those things to get the chemical you want, and then converting that into a powder or a liquid that you could use in another product. So it was really a fascinating job and a great opportunity.
No, but you didn't make the final product, like the final tablet or mix.
Yeah, well, then I would hand it over to the other R&D group at Amway that would formulate the final tablet and then run that in the manufacturing facility we had.
Because I know the big thing with supplements, especially when you're using botanicals, is potency. You know, how things over time lose their potency.
Correct. So my job was to make sure it still had the potency after we'd done the conversion from plant to powder. Their job, the formulator's next, was job to put it into a format that would maintain that potency over that time period. And really, with a lot of those phytochemicals, it wasn't that difficult to maintain the potency of some of them. Now, with vitamin C or other things like that, you have lots of issues with that. But some of the things we were dealing with were much more stable.
Now, did Amway grow these in the United States, or were they all over the world?
We grew all over the world. We had a farm in Brazil, large farm in Brazil. We had a farm in Guadalajara, Mexico. We had a farm in Washington State, and then we had an experimental farm we built in China while I was there.
Amway, as far as I can see, maybe Starkist will come next, but is one of the most international companies you worked for, in that you traveled and you worked with all kinds of products for different countries. And so what you made for us was different than what you made for Asia, then different than what you made for Russia. So let's talk about Amway, because I used to be fascinated. I used to all the pictures you would send And you were at different places and vacations, and sometimes you just were able to vacation, but you also lived in Europe for a while.
Yes. So after I finished about 7 years with Amway in doing the research, the job with the botanicals, I moved over to lead their technical arm, which was quality, regulatory, and the product development for Europe, Russia, India, and Africa. So we covered, in that point, we were in about 35 countries in that sphere. So basically all of Europe, three countries in Africa. But I spent a lot of time traveling. Spent a lot of time in India because we were opening that market, and we started a plant up there also in India during my tenure. And that was a fascinating opportunity to really understand the differences, because vitamin supplements, which was primarily our biggest selling point, but I was also responsible for beauty products and home care products, and the regulations are different all over the world, and how you can sell it and what you can sell it. So not only is going to market different, but what you're allowed to say about it. So we had labels for, now luckily the EU has helped because you don't have quite as many countries that you have to deal with, but a lot of the Eastern European countries still have their own laws. And I always like to say EU law is like baking a cake. The cake is the same as the EU, but each country may ice it a little bit differently. So each country has a little bit different flavor of what they do. So we would make product for them, we'd make products, and you had to really, when you're looking at a product to bring a new product out globally, you have to look at what the regulations are and how you're going to have to change it, and how you can formulate it so you have the least number of iterations of that product, because you don't want to, you have 35 countries, you don't want to make 35 different products. You want to try to make like 6 that would fit everybody.
Were they all made in the same facility, and you just had to make sure you left an ingredient out of this one or put one in that one and then label them different?
In general, yes. We had different. We had ones that were made in our factory, most of the stuff for the mic were either made in India or in the U.S. So all the stuff for Europe was made in the U.S. All the stuff for India was made in country, and then you would just run separate formulas. So it was all different formulas. So we had thousands of formulas because of the changes you had to have for the different products.
Now, did they have things like they thought certain minerals or vitamins were more important than we do?
Yes, some countries have minimum. A really easy way to explain it is the U.S. U.S. has some very, very relatively straightforward laws as opposed to supplementation, and it really hits on minimums, right? You have to, at the end of shelf life, have the minimum amount you have on the label. Canada also has maximums. So the challenge there is you can't be above this at the start of your shelf life, especially if something that dies off, but you can't be below this when you finish selling it. So Canada was tougher because it boxed you in. And so that's an example of other countries may have laws that allow this or not, or their minimums may be different. So, for instance, Turkey's level of vitamin D minimum may be one level, but Europe's may be way up here. And then, so the issue, but you may not be allowed to go higher, so you may have to make a separate product for them because they have such a low level that you can't go too high. You can't use the same product for it.
Now, do these countries change this stuff very often, or is it pretty stable from year to year?
It depends on countries like the U.S. and the EU tend to change things very, very slowly. And it tends to be more along the line of, say, the EU just banned titanium dioxide, which is a whitening agent. So that's a big deal in the world of supplements and in beauty products. But we saw that one coming 4 or 5 years ago. Some of the countries that are newer to regulations are changing quite a bit. And it also depends on what countries they use as a guide for the regulations. A lot of countries kind of use the FDA as a base guide and then kind of do some modifications on that. But others may go on the EU standard. They may go on somebody else's or China's standard. So that really kind of helps you start to put things into buckets, depending on what they kind of used as their boilerplate or their blueprint for the way they set up their food regulations.
Now, do other countries want to take supplements and vitamins, all stuff, as much as the U.S. does?
And I'll even question that, because I think The U.S. likes taking supplements, and we have a lot of very good supplement companies in the U.S. I'll be right up front with that. But I think if you talk to experts, they still say, well, you shouldn't take supplements, you should just eat a balanced diet. But we all know that most people don't eat a balanced diet, so they want to take the supplements. I think depending on how developed the country is going to be how receptive they are to taking those. But it is also fascinating when you go to a place like India where you have Ayurvedic medicine, which is the traditional Indian medicine, or you go to China where you have traditional Chinese medicine. They're much more receptive to that than they are to traditional Western supplementation. So you've got this interesting blend of Western supplementation and that is also trying to formulate into it some of the Ayurvedic or TCM, traditional Chinese medicine, into the formula to tailor it to those markets. So kind of old and the new coming together. So you're seeing a lot of that. And as I was leaving Amway, we actually launched a product that was a tablet supplement, but it was Ayurvedic formulations. So it really was trying to hit that, make the old Ayurvedic formulas more accessible.
Well, what about countries that are malnourished? Do we ever push any supplements into there?
Most of the time, malnourishment is really more on a macro level than a micro level. So if you're malnourished, you probably have bigger issues than not getting enough of one vitamin. Now, there are specific examples in countries where you may have a very low vitamin A level in Africa because they don't have a lot of the red color, the red or orange color in their diet. But in general, that also is usually paired with just an overall lack of calories or unavailability of protein. So that's really part of the challenge. It's rarely as simple as take this tablet and you won't be malnourished anymore.
I just know my doctor's always pushing vitamin D on me because I live in Western Pennsylvania where we don't have any sunshine.
And he's probably absolutely right. I take it every day.
Yep. So that's what we do. So but you went to some pretty interesting places when you lived in Europe. You had to travel to Russia.
Traveled to Russia a number of times. I traveled to India about 27 times. I traveled all throughout Europe. Got an opportunity to go to Turkey. So it was a fascinating opportunity to see. Plus, with Amway, I also was in China a number of times. So really great opportunity. Mexico, Brazil. So really great opportunity to see the world, if you will, the U.S. Army type of thing. But and really most of it was mostly work. But it was a really great opportunity. Understand them, work with them, see the culture, and see what they're working and see how the country's, what's important to them is always an interesting thing to see.
Basically, you could say to somebody who wants to be a food scientist, if you really want to travel, this is a good job.
It can be if you get in the right company or if you get in the right niche of food science. As I said, food science is such a broad area because, look, I've worked on frozen foods and supplements, and those things are pretty far apart. It really depends on what you're doing and what you want to do. But if you have the desire and the drive to do that, there's great opportunities in food science to see the world.
Now you're at Starkist doing tuna.
We're doing tuna. Yes, we are.
Yeah. So tell us about tuna. I got to tell you, the most shocking thing I learned about tuna was, I don't know why, but I thought tuna fish were this big.
No.
A friend of mine used to work at Starkist. He sent a picture, and my arms aren't big enough. I mean, so I didn't realize tuna fish were they're like little whales.
They're very large, yeah. Especially it depends on the species. So tuna is again, as I talked about, each industry has its own twist, and tuna is a very, very, very different industry because of what you're dealing with. You're dealing with a product that is a natural product, and so because of that, it is also very different sizes. Like you said, we can deal with fish that are 5 pounds and that are 100 pounds in size, and on a given day. So unfortunately, what that means is there's just not a lot of automation in the cleaning of fish, and you have to, it's a very manual process to get the fish in, get them cleaned, to get them prepared to go into a canning process.
And where's your main processing facility?
So we have facilities in American Samoa, and we have facilities in Ecuador.
Okay. Have you got to travel both those places?
Yes, I have. And yeah, it's a really interesting. It's a great opportunity. Both going to both plants. It's really the great people that work there, and we move a lot of fish. And we put fish in cans. We put fish in pouches.
It's probably a really messy process, right?
You know, fish in itself, it does have the smell of fish in the plant, right? Because that's what you're processing. Just like any other plant is going to smell, tomato plant's going to smell like tomatoes. So, but it's a very organized process to clean a lot of fish, and it's amazing how quickly we can move those fish through the process. Because they come to us frozen, because fish are wild caught, so they're school caught out in the ocean. I always love when people say, you know, does your fish come from U.S. waters? Well, we wouldn't make a lot of fish if it was only U.S. waters. And Samoa is a very large processing facility. We employ about 2,000 people there. So we're the largest employer in American Samoa. So we're really involved in the community there, really involved with throughout the island. We do bring people in from other islands also to work in the facility. So it is it's a real great opportunity. And the cannery's been there. We just celebrated 60 years this year.
Wow, that's amazing. It is a beautiful island too, right?
It's a very beautiful island. It is it's not touristy, but it is beautiful. And you know, it's great to work with a brand when you've got a great mascot. Everybody loves Charlie. So it's the first time I've really worked with a brand that has, you know, kind of that fun side to it too. Everybody recognizes it.
Tuna's always been in cans. Why do you think it went to pouches?
Well, Starkist was the company that really started pouch tuna. And again, that's for convenience. We joke that millennials don't own can openers, but in reality, it's convenience. And if you look at the tuna in the pouch, here we've introduced all these flavors. So you can get hot buffalo or spicy Thai or herb and garlic, all these different flavors. So you can just rip them and eat them right out of the pouch. So we really kind of changed in the opportunity. You don't see people eating out of the can, right? You're doing that so you can make tuna salad or you can put it over pasta. What we're trying to do is create more of a ready-to-eat experience for consumers. And by the way, we also have moved outside of tuna. We're in chicken now, so we have chicken in pouches also with similar flavors.
Oh, I didn't know that. Well, that's good to know. So I was a traditional tuna fish eater. You know, you bought the can of tuna fish and you made the tuna salad. Now, when I don't know how many years ago, they made it very popular, you would have tuna in the water. So they can it in water. And somebody at Starkist told me, if you really want good tuna, get it in the oil. And so we have probably for the last 10 years bought our tuna fish in oil. But I'll go to the grocery store and sometimes I have to dig through the dig back, or look all over to find anything in oil because people have been sold that idea that water is better, oil is bad.
So water is a holdover from when we were all on low-fat diets. This was pre-Atkins. We all wanted low-fat. So one of the ways that was thought to do that was just get it in water so you don't have the oil. Well, as a food scientist, you realize that fat is where flavor is carried. And so tuna in oil always tastes better. And if you use it with the oil, you don't need as much mayonnaise when you make a tuna salad. So essentially, you're putting the oil you want in, not the oil you don't really want in more mayonnaise. The other thing I think is interesting, we make a product called EVOO. It's in a gold can with gold writing on it.
Yes.
Extra virgin olive oil. It changes the game altogether.
I know. I've had it.
It makes it amazing.
And it's hard to find.
We're trying to make it more available.
Yeah, but that was the one thing I said, we tried it in olive oil and I said, why do people in the water it's just kind of dry and the mouth feels wrong and
you're from Northeast, so you probably eat albacore in water. Right. So there are a number of species of tuna. So the primary one that we buy for when you buy Chunk Light is called Skipjack. Albacore is very popular in the Northeast, and it is more of a tastes like breast meat chicken, right? It is more of a dry, lot less fish flavor to it. Then you've got Yellowtail, which is technically a light tuna also, but it is much more flavorful, and you'll see it called out in a number of different brands, and in our brand, our EVOO. Yellowtail has a much more buttery flavor to it.
But does it say it on the can, or is it just?
Yes.
It does? So I have to look.
Yeah, we make an EVOO, and my favorite is our EVOO with garlic. So it's a Yellowtail in EVOO, or yellowfin tuna in EVOO with garlic.
I have to try that. You mentioned eating on pasta. I never thought of that. Seriously, I tuna fish salad, and that's it.
It's amazing how many things you can put in tuna that's not tuna salad.
Yeah, so you just put it on top of pasta, cooked pasta?
Yeah, especially the garlic one, because it's already got the flavor in it with the olive oil.
Oh, I'm going to have to try that. Of all the things you've worked in, what was your favorite?
That's a real tough question, because for me, it's really more about the people I've worked with in the various jobs than it is the products I've worked on. Because the people make the job fun. And the stresses and all are also people related. So I'd say when you've got a good group of people, and I'm talking cross-functionally, not just in your R&D teams, your quality teams, when you have a really good group of people you enjoy being around, it makes coming to work much more fun. And so I'd say for me, it's more about the places where I've really had better groups of people I work with that I feel like I trusted, that I feel like we're all really pushing in the same direction and we're all really engaged. And when you have those organizations, I think then it really doesn't matter what product you're working on. That's where you really want to be.
Well said. I agree with that. Now, are there any products out there that you had a big hand in making that are still out there? Because I know they change them all the time, so no reflection on you.
Quite a few. Quite a few. And, like I said, things change, right? Things change over time. So, yes, there's quite a few products out there that I've had a hand in over the years to highlight one, I don't really know. Because as soon as I say it, it's going to say, well, I didn't realize that one changed. But there's a number of products throughout the frozen food category that I've worked on that are still out there in one format or another. And I think the interesting thing is the brands that I've worked on. Whereas, when I worked in frozen food, I worked for Weight Watchers as my second job after my master's. Weight Watchers, it was a pink, you couldn't get men to pick it up. It was a pink and white box. We developed a line called Smart Ones while I was with them. Now, the whole line doesn't say Weight Watchers, it's now Smart Ones. That's the whole line. So it was interesting. That was a line that was originally developed to have 1 gram of fat. Now, that's since changed, I think, more. But that was a whole product line that kind of came out and morphed that brand into something totally different. So I feel that was one that I'm really proud of. There's a number at Amway, but they're ones that probably most people who would listen to this podcast wouldn't really be familiar with that I've worked on over time that I feel really proud of. But I think a lot of what I'm really proud of also is some of the new plants. I've worked on a number of different new plant startups and stood up new processes within plants. And I think the ones that have gone well and are still standing and running today are probably some of the ones I'm probably the most proud of.
That would be really tricky, a whole plant startup. You got to do equipment. You got to do everything.
Yeah, it's usually a long process. It's a process that usually takes months to get done correctly until you're really what you'd say running full bore operations.
We touched on this before. There's some of those TV shows that they put out, how it made, and things like that. And of course, they film only the best parts and not the disasters.
Yeah.
And I don't think people realize that some of these plants are very wet or very cold or very hot or, so on and so forth.
Right. And I think I always tell people part of being a food scientist is making messes. Because invariably when you're working with things and at the scale you are, you do make messes. It happens. It's part of the process. You try to minimize it, but occasionally things happen.
And I know we talk about all the food science part, but there's the quality part of it. And I went into a food plant once, and the first thing I noticed is that everybody had on different colored uniforms. And I don't mean 12 different colors. I mean, there was a blue group, there was a white group, and I think there was a green group. And I said, and as we walked from different parts of the plant, I encountered different colors of uniforms. And I said to them, I go, why do people have on these different colors? And they said, for cross contamination, we don't, if we see a blue person in a green area, we know that we have had a cross contamination and we're in trouble. So they know never to cross into another room because they have on the wrong color clothes. And I thought, what a fascinating, easy way to do that.
I've seen that done with jackets. I've seen it done with helmets. I've seen it done with a number of different ways.
Yeah. And I mean, what a fascinating way, like I said, to do that to keep us safe, because you can't just go visit your friends in the other area.
Right, especially when you're going cooked to raw, right?
And this was a ready to eat food company. Nothing was cooked. Okay, I shouldn't say nothing was cooked. A lot was cooked. But it was like potato salad, macaroni salad. So the potatoes were cooked, the macaroni was cooked. But when they assembled it, it was now a refrigerated product that could not, so they couldn't contaminate raw materials with the cooked materials. And so they were, I think that QA manager slept every night with one eye open, waiting for someone to call and say someone got sick on the product because you couldn't cook out the germs.
And that's one thing I've never worked in refrigerated products. And I've always worked in something that's been stabilized, either frozen or canned or some other way. So that's really an interesting part of the business. And you're right, that is probably one of the toughest areas in the food industry to be a quality supervisor or lead.
And we talk about shelf stable. And I think you and I throw that term around because we both know what it means. But I don't think people realize that it just means how long you can keep it, how long it will be good on the shelf. And then there's, this is my favorite part of a label, best by or must be eaten before. Like people think that if it says best by, they throw it away. And I'm like, no, it just means it might not be as good, but it'll be safe. But if it must be used by, then that's your date for it. It probably might not be safe anymore.
Yeah, I mean, the fascinating thing when you look at canned goods or frozen goods, they're probably good way past, probably. They are good way past the shelf life. They're technically safe. They're not going to taste very good anymore past that time. They're going to denigrate. They're not going to taste as good. But yeah, you could eat them. It's still got calories and it's still food in most cases. So it's surprising how long things will actually last in some of these packages.
I went to a celebration of a company. It was, I think, their 60th or 70th anniversary. I forget what it was, some big number. And they make tomato sauce, canned tomatoes, tomato sauce, everything like that. And the man standing next to me was from one of the canning companies. And he said that morning that they had, at a private breakfast, opened several cans of tomatoes the company had kept from the 70 years ago or whatever, and 50 years and 40 years. He goes, so we opened some that were 40 years old and the products were still perfectly good. He said, so people throw away canned goods after a year. He said, you don't have to do that.
Yeah, because essentially they're sterile.
Yeah, but they're still good. And I had a friend one time, she cleaned out her freezer, and you know how the label would say freeze by, June 1st? In July, she'd open her freezer, she'd throw all those away. And I said, why did you throw them away? And she said, well, it said use or freeze by. I said, did you read that? Use or freeze by that date. And then you can leave them frozen for 3, 6 months, a year. I said, as long as it was packaged correctly. She's like, oh my gosh, all these years I've been throwing this food away? And I said, yeah, you have.
I mean, just think about it. Bread used to last. If you go to Europe, bread lasts about 2 days because they don't put a lot of the same stuff. We have what we call ESL bread, extended shelf life bread in the U.S. now. That bread lasts amazing amount of time. It's still good. So it is crazy how and that has helped the supply chain and helped the supply and helped us throw less food away. It's crazy how much we've pushed the boundaries of how long that food can stay good.
I know it was 32 years ago because it was before I moved here. I had a box of Popsicle brand sugar-free fudgesicles. I did not like them. So I thought, I'll throw them in the sink. I'll throw the box in the sink. It'll melt, and I'll just throw away the wrappers away. And the melted stuff will go down the drain. So the next day I opened it up and I went, how are these in 75-degree weather? How are these? They're perfect. They were absolutely a popsicle.
But you know why? Because they're sugar-free.
They had all those gums in there.
Gums and starches, because you didn't have the sugar as a bulking agent. Because sugar is not just the taste. Sugar also gives it structure and bulk. So when you take all that out, you got to replace it with something.
I wrote to the company and I said, what kind of stuff do you have in here? It can't be a food product. It can't be edible. This is before I knew all this stuff. And I said, what is this? Their answer was, we're sorry you had that happen. Here's some coupons for some other product. But I figured it out later. And they were a little slimy. So I knew that it had to be some kind of stuff in there. Yeah, gums and stuff like that in there. But I was shocked to say that you expect it to melt. Like sometimes I do run home with things from the grocery store thinking, if I don't get this home in the next 5 minutes, it's going to melt and it'll be undistinguishable. And I get home and it's still fine.
Well, one of the things that I think has happened is our supply chain has gotten much better. Even the freezers at the grocery store have gotten much better at holding those things at the temperatures where they're going to last longer. So they're not at 0, they're probably at -10. Right? So they're at a better temperature. So you've got a head start when you go home to bring that stuff home. But I think it is kind of fascinating to think about how everything's changed and how it's evolved. It's continuing to evolve over time.
My mom used to freeze strawberries in containers. And so as they froze, they went down the container and made this solid strawberry block. And what came out of the market years ago was individual quick frozen food. So I thought, well, how can I do that at home? So I have wonderful raspberry bushes and blackberry and rhubarb. So I take them on cookie sheets and I put them on there and I freeze them and I gather them up and put them in Ziploc bags.
But still not the same. Yeah, it's still not the same because they're probably run through a liquid nitrogen freezer.
Yep.
So they're freezing them like that. So you're getting a real quick freeze, and you know the difference there because the longer it takes to freeze, the longer the ice crystals get, and that disrupts the membranes in the food. So a quick freeze is better for food. It keeps that integrity longer.
Oh yeah, I know mine's in slow motion, but it's better than sticking the berries in a Ziploc bag and let them freeze together.
Exactly right, because then you get a block.
Yeah, because I just use them. I measure them out, put them in smoothies, measure them out for pies. I can measure everything better. But it's just funny how if I hadn't seen that somewhere else, I never would have figured that out. Thank goodness someone else figured that out. So I know that they're doing it better. I was in a company that made frozen pancakes, and they cooked the pancakes and they took them through the tunnel immediately, and they were frozen within I don't know, but I mean just like the tunnel was 20 yards long, and it came out solid frozen, and that took 3 minutes.
270 degrees, below freezing will do that. So I mean the challenge is that that's a great way to do it. It's also a really expensive way to do it because liquid nitrogen freezers are expensive to operate. You have to keep bringing in liquid nitrogen, which is pricey to ship in. But it's pretty well used, especially for lower volume food in the food industry. Liquid nitrogen is not, or high value food, it's not unusual at all. A lot of the seafood industry, for the frozen seafood you're going to see, is going to be utilizing those.
They do that?
They'll use fluid bed freezers, they're called, either nitrogen or forced air, fluid bed. Because what you're trying to do is you're trying to get a lot of air movement because it's funny, when you're outside you put a jacket on because it creates a small layer of warmth, air between your body and the outside. Well, essentially, think about if you're trying to freeze, say, a shrimp. If you're just putting it in a freezer, it still has that pocket of heat that's in the shrimp that forms around it. When you move that air fast with a blast of air and keep air blasting, cold air blasting, it strips away that reforming bubble of heat around it, and it freezes faster. So now you've got to be careful. You can't do too much because then you'd start to dehydrate it and dry it out and get freezer burn. But there's a fine line in freezing things where you want to move that air. It's the same thing with heating when you're cooking. Air impingement. You want to put more air. So a convection oven is moving that air around more, stripping off that layer, that insulating layer of air on the product.
You talk about cooking with the air. That's where the air fryer's all. Everybody loves their air fryer.
Exactly, right. You're moving that layer, that boundary layer of away from the surface of it, which is causing the heat to penetrate faster. Because it's going to, until it gets up to temperature, it's going to continually try to create that by naturally it cools the air around it. So you get that layer of cool air, which the heat has to work at penetrating or heating up. And heating air is really inefficient. So if you blow that air off, then the heat gets right on the product you're trying to heat up. So it's much more efficient, much quicker to do it. So you're cutting your heating time dramatically.
I've not really embraced the air fryer completely, but my 91-year-old mother has. She thinks they're magical. But obviously she's the woman who was coming along when they invented the microwave. You know, she was one of the first people to have a microwave. So she's embraced all this new technology.
But you can't use it for everything. Like if you try to use your convection oven or your air fryer for baked goods, it's going to be a disaster.
Yeah. I did try it once for crescent rolls, and they were kind of fun, but not as good as the oven. But she just loves it, makes a hamburger in that thing. She's like, this is even better than... She's like giving up her grill now because she thinks for one person, she does her hamburger, and she swears she's a gourmet cook with chicken thighs. She can give you 101 ways to make chicken thighs in the air fryer.
In the air fryer. That's good. Well, it's good. You know, I think that's the other thing is that, you know, we can't, as we talk about food science, all these technology breakthroughs. Now, the industry was using called air impingement ovens, which is basically a convection oven. We were using air impingement ovens back in the 80s, right? That was the big thing, was when we started adding forced downdraft air on a cooking belt to try to cook things faster. And you can get more browning and other things with it. So that air impingement, it's been around. It's taken a while to get down to the consumer level into a format where we could use it. But I still think it's one of those fascinating things. So that's where the industry kind of had it first. We had to figure out how to get it down to the home oven.
Well, consumers are a little bit resistant to things because if they don't understand, they're scared of it.
Well, the other thing is realizes that we also have to, because I'm embarrassed to say I started my career when microwaves were relatively new. And my job, while I was a graduate student, I was co-oping with McCormick and Company. At one time, they owned a popcorn company. And one of the big projects we were working on was trying to figure out how to make microwave popcorn in the little bags like you do it now. Mm-hmm. And that was when it was brand new. And we went through a lot. And that back then, a lot of them didn't quite have the wattage to pop popcorn. You had to have get up to 1,000 watts, which were the big expensive ones at that time. Because people were still thinking they're going to cook turkeys in them. So these things were huge. I popped a lot of popcorn when I was in graduate school, trying to figure out what's the right ratio of oil and popcorn, the right moisture in the popcorn. So we did a lot of popcorn studies, and then trying to make seasonings to go with that popcorn in the bag, and how do you season it so that it's seasoned when it comes out of the bag.
Okay. So do you know who the first company was to come out with the microwave popcorn?
I'm going to guess it was Redenbacher, but I may be wrong.
It was General Mills, but I don't know what brand it was. General Mills did. I actually, since we're almost the same age, when I was in college, I took a class, microwave technology.
Wow.
And so my family has always said to me, they're always like, oh, Mom, how long should I cook this or whatever? My husband always called me Little Miss Microwave because I kept telling everybody there's only 3 things that heat in the microwave. If it's not water, sugar, or oil, fat, it doesn't cook. So a piece of paper doesn't cook, and obviously can't put metal in there. So I would tell them, and the order is fat cooks the fastest, then sugar, and then water. So if you put in, vegetables, they take longer than if you put in a piece of meat or a piece of bacon. So I'm always trying to educate my family through my whole life on this microwave thing. But I took this class, and the microwave was huge, and we cooked a prime rib in this thing. We baked cupcakes and cakes. We were doing everything as experiments, to see what you could do. But our professor came in one day and he said, I have a surprise for you. He said, this food company sent this to me. This is a sample that hasn't come out yet. And this is 1983. I'll go ahead and say the year. And he put in the microwave this bag and made microwave popcorn. Now, none of these young people can remember the first time they tasted microwave popcorn because they've had it too long. But we had been air popping, which is terrible, popcorn for however long in our dorm rooms, and theater popcorn, which is notoriously terrible for you and not reliable. So here we are sitting in this classroom, and he passed around this microwave popcorn, and I'm telling you, heard music. It was the most amazing thing any of us had ever tasted. Now here was the downside. I had that handful of popcorn. It didn't come out on the market till 1986. For 3 years, I kept telling people about microwave popcorn. They looked at me like I was 3 heads. And it came out of the market. But like I said, I remember the first time I tasted it because what the quality of what we had for all those years. And now suddenly is so much better.
Yep. And the funny part is that I can remember the biggest issue was you had to have a microwave over 1,000 watts. Well, no one knew what their wattage of the microwave was. And so there was 1,000 complaints because people get it and they put it in their 600-watt microwave and it would just melt the oil and just sit there. It wouldn't get enough, it wasn't enough energy to pop the popcorn.
Right. Oh, and people started doing that, testing their microwave, see if it was any good by popping popcorn.
That was the standard for a while.
Oh, and even if you went into a store to buy a microwave, they would show you how good your microwave was because it could pop popcorn. Yeah. But that was probably the funniest thing because I came out knowing this. But I do have to tell you, to age ourselves even worse, that was the same professor that introduced us to this amazing thing we'd never seen before, which was a cordless phone. Not a cell phone, a cordless phone. He can go all the way to the end of the driveway and get his mail while talking on the phone.
Oh, wow. Yeah. And now we take that, now we can walk across the country and do that.
Yeah. Oh, and we can watch movies and videos, and what a beautiful time to be alive. I don't think anybody else appreciates this like we do.
It's crazy. It's crazy.
Well, I think that we have covered everything we need to cover about the food industry and about you. Do you have any parting words?
I don't really have parting words. I think the main thing is because I'm planning on being in this industry a little bit longer. And I think the one thing that I think gets me up out of bed every day is the fact that I have an opportunity to learn something new every day. And that's what really, I think, is the most fascinating thing about food. I got into food because I thought, well, people always have to eat. Sounds like a great job. I've got some job security there because people always want food. And I think what's kept me in it is just the way it changes and the flavors change and the tastes change and what people want changes. And I think that's what continues to get me out of bed every day. And I think that's why I find food science and food related things so rewarding is just because of that opportunity to keep learning something new and always finding out something interesting.
Yeah, I think it always evolves. It continues to evolve because it's not the same as it was 20. It's going to be different 20 years from now.
Yeah, there's nothing more fun than walking to a grocery store and looking for new products. And if you're one of those shoppers that goes and gets the same thing every time, but that's not me. I'm the kind of person that they send me to the grocery store and I come home with half my cart stuff that I didn't have on my list. And I think that's the curiosity a lot of people need in the food industry, to try to see what's out there and what are the cool things that someone else is doing.
Yeah, I'm pretty bad when we go on vacation to different parts of the country, different parts of the world. First place I go is the grocery store. Yeah, I want to go to the grocery store. I want to see what they have that we don't have. And then if we drove in the car, we're in trouble because now we're going to bring home all these things I found.
Yeah, I'm totally with you. I totally understand. Same thing. I mean, if I get in a grocery store, we're going to be here a while.
It's a field trip for me. And my husband knows it. He's like, okay, let's go to the grocery store and see what we find. And we're, when we go out of the country, I went to Ireland once, and one of my favorite foods is rhubarb. And there's lots of people in this country don't even know what it is. And Western Pennsylvania, we have rhubarb. So I walk into a grocery store in Ireland and they have rhubarb yogurt.
Oh my golly.
I'm like, this is the best thing ever. So I figure out that it's really yogurt, like vanilla yogurt, mixed with rhubarb sauce, because you have to cook rhubarb. It's not raw. So I make my rhubarb sauce. I have my yogurt. I mix it together. I eat it all the time.
Little taste of Ireland for you there.
Yeah, I brought it home with me, but you will not find that in the United States anywhere.
That's the other fascinating thing is just the tastes in different countries and the number of different things that you taste there and you just can't find other places. Now, the beauty of the industry, though, is you can find it now. You're starting to be able to find it in different stores. Stuff that you used to be able to never get, now it's all being imported.
Yes. Yeah. And I have found some, well, there was one time I bought dark chocolate Kit Kats in England.
Really?
Mm-hmm.
Wow.
And I came home and there weren't any here because I remember seeing them. I do have them now, but they didn't have them. And I called the company and they said, well, you don't understand. Our European company and our US company are two different companies. We're not the same, even though it's the same name. And I was like, I think it was Nestle, whatever. But anyway, so they said, those are only made in Europe. We don't have them here. I said, well, can you send me some? They said, well, no, they're a different company. I can't call them and have them send them to you. So I had the opportunity to go back to Europe a few years later. And I purposely left some room in my suitcase. And I brought home, I think, like 50 Kit Kat dark chocolate kitty bars.
Wow.
and I think they now have them here. I think I saw them.
Wow. Yeah, probably do. Yeah, I was going to say, how long did that last?
That's only taken 28 years to do. Well, Barry, thanks for spending all this time with us. We have enjoyed it very much, and I hope everybody's learned a little bit about the food industry. And,
my pleasure.
And obviously a little bit about you.
Thank you.
And I took a few things away from this I learned I hadn't thought about or hadn't learned. So, like you said, it's always something new every day.
As usual, it's a pleasure, Maureen. Thank you very much for your time.
Thank you. Talk to you later. Bye-bye.